Good afternoon, all of you. In the previous class, we studied about enthalpy of solution and enthalpy of dilution. And today we will be dealing with a very important topic of thermodynamics, which is spontaneity. So the word spontaneity or a spontaneous process is a process which happens naturally. So the word spontaneous means natural impulse or without any external effort or force. So if a process is happening without any effort or without any external force, we can tell that particular process is spontaneous. For this, we can take an example of a biological process which is growth. So growth of a tree, a growth of a human being, anything. So it happens without any external force or external effort. Yes, we can provide fertilizers or something, but if we don't provide also, it happens. So if we plant a tree, it grows. We don't need to put an extra effort for that. So we can tell it's a spontaneous process. With just its own natural impulse, it grows. So it's a biological process. Similarly, if we consider physical and chemical processes also, we can explain spontaneity. This is an example, or a ball or a stone falling from a big height. So that's a spontaneous process. Once it starts falling, it will not stop. It will continuously go till it reaches a level. So that also without effort it is happening. So we can tell it is also a spontaneous process. And if we take some hot water in a glass and if we keep it outside, what happens? After some time, the heat of this is getting transferred to the surroundings. The heat of this is getting reduced and it will become normal water. The hot water loses its temperature and becomes a normal water. So there also we can tell it's a spontaneous process as we are not providing any external force or effort, it is happening by itself. The heat is getting flowed or a heat is getting transferred from that hot water to the external surroundings. So here we can see another fact also. Why it is happening? Why it is happening as a spontaneous process? Because the flow of heat is unidirectional. The heat flows from higher temperature to lower temperature. It never flows from lower temperature to a higher temperature. And if we want to reverse this, we need to put a external effort. So that's a fact there. If we want to reverse the spontaneous process, we need to give an extra effort. Or now we need to provide some amount of heat to increase the temperature of this water. So hence it is not a spontaneous process. But initially when we kept this water outside, the heat was getting transferred from a higher temperature object to a lower temperature object. So hence that was a spontaneous process. But in this case, when we want to reverse it, we need to put some extra effort. So hence we can conclude that spontaneous process is irreversible. It cannot be reversed without any external effort. Another example we have when we try to burst a balloon. So when we burst a balloon, the gas inside or gas present inside the balloon is getting distributed to the atmosphere. It is not staying like that. So when we burst it, whatever air particles inside the balloon is getting distributed to the surrounding or to the room. So that is also a spontaneous process. We are not doing any effort for that. We are just bursting the balloon. So once the balloon is burst, the gas particles inside are equally distributed to the atmosphere. So all naturally occurring processes, whether chemical or physical, will tend to proceed spontaneously in one direction. So to reverse this direction, we need extra effort and that becomes not a spontaneous process. Hence, spontaneous process is unidirectional. So all natural processes will be spontaneous because without any effort it is happening, then it is spontaneous. So for a spontaneous reaction if we consider, we will have a thought like when we keep the reactants together, When the reactant come close only, it will form product. So that is actually a myth. So this is what usually people think about a spontaneous reaction. So whenever the reactants come close, suddenly it will form a product. So that is not actually a fact. That is a myth. So this is an example to break that myth. So these two gases are actually reactive with each other. They react with each other and they form spontaneous reaction also. But still, these gases can be mixed at room temperature and left for many years without observing any bigger changes. So they form spontaneous reaction, but they can be kept for years without observing any major change. Why is that so? Because the reaction between hydrogen and oxygen happens in an extremely slow rate. So it happens in extremely slow rate and they can be called as spontaneous reaction. So spontaneous reaction doesn't mean that they happen in a very fast rate. For example, as we have seen in the first example, they suddenly come close, they suddenly make product, nothing like that. So spontaneous process can happen within years also. It can be done in slower rate also, but still it should happen without any external effort or force. Then we can tell it's a spontaneous reaction. And what is the driving force of this spontaneous process? So what will be the condition for us to call a process spontaneous? So we will see the definition, how we can define a spontaneous process. So having a potential to proceed without the assistance of external agency. So this we can tell. It might not be in a higher rate or smaller rate, whatever it is, having a potential to proceed without assistance of external agency. Then we can tell it's a spontaneous process. And one more fact is that these cannot reverse their directions by their own. So when we need to reverse the direction of a spontaneous process, as we have seen, we need to put a little effort. So these are the two factors for a process to be spontaneous. It should have a potential, it should have an ability to proceed without any external assistance and will not be reversed by their own. We told about biological examples, growth. So will growth will be in its reverse direction by its own? No, every spontaneous process is like that. Whether it is biological, whether it is physical or chemical, whatever it is, it won't reverse by its own. So this is the final definition which we have for a spontaneous process. A spontaneous process is an irreversible process and may only be reversed with some external agency. This is the main definition. So now we have a question. Is decrease in enthalpy a criterion for spontaneity? So whenever we have seen reactions, we have seen spontaneous reaction with decrease in enthalpy also. So is that actually the real criteria to be spontaneous? So when we have seen this example, there also initially it was at higher temperature and slowly the enthalpy was reducing, or the temperature was given out and temperature reduced. There also decrease in enthalpy is happening. So decrease in enthalpy is stability. This we have discussed earlier. So in this case also, it is not enthalpy, but it's an energy decrease. So in the higher stage, it was having more of kinetic energy. It is even same for the flow of water. When kinetic energy is more, it tends to comes down. So it gives out kinetic energy, acquires some potential energy, and finally it comes to rest and gives out potential and kinetic energies. So more energy is less stability. So actually, can we tell that spontaneous process is giving out energy or giving out enthalpy? Can we tell like that? So we will see some examples of this category. Half N2 plus 3 by 2 H2 gives NH3, the formation of NH3, and there we get the reaction enthalpy as negative 46.1. So hence it is a negative, it is a exothermic process also. And I need to tell all these reactions are exothermic and they are spontaneous also. So when we see reactions, most of the exothermic reactions are spontaneous only. So with this, can we conclude that the enthalpy decrease, which means spontaneity? No, because we have a very familiar example, which is the melting of ice. So when ice is melting, are we doing any external effort for that? No, we are not doing any external effort for ice to melt. So hence we can tell it's a spontaneous process. And if we need to form this water to ice, do we need to put some effort? Yes, we need to decrease the energy. Then only it forms ice in room temperature. So heat is being taken to this. So it is an endothermic process. So the ice absorbs heat energy from the surrounding and it melts. So it absorbs energy and melts means it is endothermic process and still it is spontaneous. So we can conclude that spontaneous processes are not always exothermic. It can be endothermic also. So we do have another conditions for that. We cannot tell exothermic and endothermic as a condition for spontaneity. We have some examples which are endothermic also here. So half N2 plus O2 giving NO2, the formation of NO2, and the reaction enthalpy is positive. Hence we can tell it's an endothermic reaction and it is spontaneous also. These two reactions are also spontaneous, but hence it is having a positive value, it is endothermic also. So carbon graphite form plus 2S giving CS2 liquid. So formation of CS2 with enthalpy change of a positive. So positive 128 kilojoules per mole is being given out to the reaction. So this much of energy is we are providing to this reaction. So hence it's an endothermic process and it is a spontaneous process. So we cannot tell we are providing, it is actually absorbing by itself. Hence it became spontaneous. So this is an energy diagram for a process and we can check whether it is exothermic or endothermic. So reactant enthalpy is at a higher stage and product enthalpy is at a lower stage. So reactant is giving out some enthalpy and becoming product. So from reactants, energy is losing to become product. So hence we can tell it's a exothermic process. Reactant gives out energy and becoming product. So it's an exothermic process. So this much of enthalpy is being evolved in the reaction. So given out in the reaction. And one more graph we have where the total enthalpy of product becomes a higher value and total enthalpy of reactant in a lower value. So lower energy to a higher energy it is traveling. So it is actually absorbing some amount of energy and becoming product. Hence the net absorbed or net heat absorbed is this much. And we can tell it's an endothermic reaction. The reactant getting energy and getting energy reaching this level to become product. So this reaction is an endothermic reaction. In both the cases, we can see spontaneous processes. So both the cases we can see spontaneous reactions. So therefore decrease in enthalpy may be a contributory factor for spontaneity as we have a lot of reactions which are exothermic and they are spontaneous also. So most of the spontaneous reactions are exothermic, but still we cannot tell it as a fact as there are some reactions which are endothermic and even spontaneous. So contributory factor we can tell for spontaneity, decrease in enthalpy is a contributory factor, but it is not true for all the cases. This is what we conclude. So spontaneous process is a process having potential to proceed without any external assistance and the reactions which cannot be reversed by their own and they are independent of increase or decrease in enthalpy. That's all about spontaneity. So we are concluding the class. Please prepare notes with reference to textbook and submit it. Thank you.